Okay, I'm Hernan Wilkinson. He's Maxi Joel Cabezón Alvarez, and we're going to talk about advanced refactoring in Cuis, Smalltalk, and why it is important. Whoa. Whoa. Okay, so why automatic refactorings are important? I'm not going to answer that. I'm going to let Steve answer that. So Steve, please let us know.
It's a very good question.
Can we? Well, let me do something. The sound is not working well, so I'm going to do this.
Clear answer.
Okay, so why are important the automatic refactoring? Steve, please.
It's a very good question, and it's got a very, very clear answer. Developers. The key to .NET, the key to industry transformation, the key to success is developers, 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 developers.
Okay.
Is it clear? Okay, thank you, Steve. Thank you very much. So why automatic refactorings are important? Because our main users are developers, and we need our Smalltalk tools to be up to date and compete with current IDEs of other languages. If not, we will fall behind, as is happening somehow. So that's why we need better automatic refactorings, better tools, because we don't want to fall behind. We used to be the best IDE for programming, and we should be the best one again. So I'm going to show some automatic refactorings done by students at the University of Buenos Aires. I'm going to show the work of Marcelo. And the first one I want to show is the detection of repeated code based on AST equivalence. So here I have an example. So we had this behavior before, but we were using string comparison. We were comparing strings to look for similar code. And that, of course, doesn't work because in the previous version, this collaboration would not be seen as equivalent to this one because there are more spaces. But now, if I select this one and I want to extract, okay, I don't care about the name of the new method, it will recognize as repeated that those collaborations in the same method or different methods, okay? So now if I refactor, I will see self-keyword, keyword, and so on. It works also with many collaborations, not just with one. So I can select these two, do an extract, and it will show me the same code on the same method, different method, and it takes care of, for example, selecting these two collaborations. So it will not extract the first one and the second one. It will not recognize them as repeated, but just those that are in the middle. Okay, these are different methods. And it works pretty well with very complex collaborations too. For example, we have here this comparison of years and months and whatever, with on different situations, different way of formatting the code. But this one is the same code, but with different names for the parameters. And sadly, that's not done yet. That's part of the future work. But if we come here and select this, we will see that it will recognize at least these two different formatting code, but are exactly the same. So it's very useful. For example, if you want to do the Gildrow SCADA, and you come here and you want to make this code a little bit nicer, just a little bit, at least, you can just select this, and it will show you all the places where you can remove the repeated code. And for example, also, let's do it here. Okay, all the places. Well, it's not showing. Yeah, all the places where that code is repeated. It's a very useful tool. It helps a lot to have better code. And there's some future work, mainly recognize code that is the same but with different variable names or parameter names. And we want to use that also for the struct temporary and the struct parameter refactorings that we already have, but we are not using the comparison yet. Another refactoring is the struct parameter object. The struct parameter object is one that creates a class from a set of parameters. So for example, here I have this method, customer with identification type number. And if you look at this, ID type and ID number are objects that are passed as parameters all the time. So it makes sense to create a new abstraction for that. So instead of doing that by hand, you can come here and do a struct two parameter object, and you can select the parameters that you want to struct and create a new class, for example, customer ID. Let's call it like that. And it will, we can select the scope of the refactoring, and it will create a new class, customer ID, that is instantiated with the ID type and ID number, that has an instance variables, the ID type and ID number that were the parameters. And just, you know, it will give you the right getters and setters if you need so. In this case, we didn't need the setters. And if we look at the method, so now it's not called customer identified as, it's called ID type, ID number. So we should rename this, but it's using that customer ID. So this should be called a customer ID. And where it used the ID type now is it acts the ID type to the customer ID, the same with the ID number. Okay, so it's a very useful tool. And if you look at the senders, before, let me show you. Okay, we had, what is it? This is what we have now. Okay, no, this one. Okay, we used to have this one, where the ID type and ID number, I'm sorry, this one. And now, after all the internal refactorings it made, we got this one that instantiates the customer ID class. Okay, what else? Sorry. So there's a lot of future work on this refactoring. For example, reuse existing classes. We have to improve the names of the variables and messages. And currently it doesn't support live typing scoping. And we're going to do that in shortly. And that's all I wanted to show first. So now I think it's better if we come here.
Bueno, yo voy a hablar en español. Hola. Sí, ahí está. Bueno, yo voy a hablar en español, voy a hablar del refactoring move instance variable. Move instance variable es cuando movemos de una variable instancia de una clase a otra. Vamos a mostrarlo. Tenemos una clase acá que referencia, es un bank customer, un cliente que tiene una variable instancia country y una variable instancia libsat que representa la dirección de nuestro bank customer. Para hacer el move instance variable, hacemos clic derecho en la primera instancia, refactoring, move instance variable, seleccionamos cuál es la variable que referencia a la clase de destino, en este caso libsat, y acá tendríamos que ingresar cuál es el tipo de la variable, pero como tenemos lifetime instalado, si corremos los tests o corremos cualquier colaboración, lifetime puede autocompletar este campo por nosotros. Entonces vamos a correr los tests. Ok. Vamos a mover otra vez la variable instancia. El live typing autocompleta ahora con el nombre de la clase. De todas maneras, este campo es autocompletable, así que podemos ingresarlo a mano también. Y ok, una vez ejecutado el refactoring, todas las referencias a las variables se reemplazan por getters y setters y la variable vive en la nueva clase. Para trabajo futuro, este refactoring puede ser mejorado con el refactoring self-encapsulate field. Tenemos que mejorar algunas validaciones cuando existen nulos. Eh, eh, bueno, crear distintos getters y setters cuando existen en la clase de destino. Esto es algo que está pendiente. Y mover un conjunto de variables e instancias, porque actualmente solo mueve una. Bueno, el otro refactoring es el move method. El move method es más conocido, es cuando se mueve un método de una clase a otra. Vamos a verlo. En este caso, en nuestra misma clase tenemos un método que se llama HomeAddress, que si bien referencia siempre a la misma variable, entonces por ahí debería existir en la otra clase y no en esta. Para moverlo, hacemos clic derecho, refactorings, un método. Nuevamente elegimos cuál es la variable que referencia a la clase de destino. Acá este campo podría ser autocompletado con live typing. Corremos los tests. Ahí se autocompleta el campo. Y listo. Luego de mover el método, se reemplaza por una delegación para que sigan funcionando todas las referencias al método. Y el método vive en la clase de destino. Bueno, todas las referencias que tenía antiguamente el método a libsat fueron reemplazadas por self para que el comportamiento se siga manteniendo. Bueno, como trabajo futuro de este refactoring es poder mover métodos recursivos para que no quede haciendo una doble recursión entre dos objetos. Y bueno, el último es de los que al menos me toca a mí presentar, es el extra class, es cuando extraemos una clase de una clase existente. Para esto vamos a extraer lo que es la información de contacto de este cliente. Vemos que tiene teléfono, código de área y mail. Una nueva clase. Damos clic derecho. Refactoring. Extra class. seleccionamos cuáles son las variables de instancia que queremos extraer. Y automáticamente nos marca en azul cuáles son los métodos que referencian esa variable de instancia. En este caso, podemos seleccionar cualquier método, pero bueno, elegimos estos dos. Se crea la nueva clase con las variables de instancia que seleccionamos. Se realiza un método por cada método que seleccionamos. Y se crea la nueva variable de instancia para referenciar este nuevo objeto. Corremos los tests para mostrar que el comportamiento se mantiene. Como trabajo futuro, el extra clase es favorecer la inmutabilidad porque crea muchos getter y setter cuando uno extrae una clase nueva para poder seguir manteniendo el comportamiento. Y bueno, y mejorar la performance en lo que es el movimiento de las variables, porque cada una de las variables que se mueve requiere una recompilación de toda la jerarquía para que siga funcionando.
Well, I want to mention that all these refactorings were implemented as part of his thesis, his master's thesis, and he got his degree because of that. So thank you very much, Maxi. Congratulations. All the future work, we didn't do it, or he didn't do it, because it can't be done with current refactorings, like inline or renames and those kind of things. So now, I have almost 15 minutes for a complex demo. So I'm going to try to, voy a tratar de hacerlos perder en lo que voy a mostrar. So this is a common example I use at the university about, how to write good code and use automatic refactorings to get there. So the first thing I want to show, yeah. Here we have this import test. This is a set of classes that import some data from a CSV file to a database. And if we run the test, we can see they are not running. What's going on? Something, okay, yeah. Something got wrong here. Okay, they are running. And what's the thing I want to change here? This class, the test, has a reference to the database session. And all the code related to querying the database with the number of customers with certain ID and so on, is in the test. And that doesn't make any sense. You should have a class that encapsulates the access to the database, so you can then implement that with different implementation, like the persistent one, the transient one, and so on. So how can we do this? So what we have to do is we have to extract the session from the test, and all the code related to that instance variable that is using the session, we have to move it to a new abstraction that is going to represent that access to the database. So, sorry. What I'm going to do is a struct class, and I'm going to create a persistent, I'm going to call it customer system. This is the name of the new variable that is going to reference the instance of persistent customer system. I'm going to call it customer system. And I'm using here the idea of having systems, something that we talked about a long time ago. Gabi gave a talk many years ago in the Smalltalks. And I'm going to move session, and also I'm going to move all the methods related with it. The one that looks for a customer, giving an ID, the one that gives you the number of customers. I'm going to move the setup, and the tear down, but not the others. So if I do this, now here we have the customer system. Persistent customer system references the session, and it gives you the getters and setters and all the these messages that were moved from the test to here. If we run the test, everything should run, and we can see it's running. But now we have to start doing some stuff. Doesn't make sense. Wow. To call this message setup, because we don't want to set up the customer system, we want to start it. So what I'm going to look is at the implementation and see also why it's sending the test as a parameter. It doesn't make sense, neither. But it's doing that because the previous version of this method had an implicit return self. So that's why it's passing self as a parameter. So as I said, we don't need that. So I'm going to remove that variable, that parameter, sorry. So I cannot do it if I don't remove this first. Okay, let's see if it works. Now I'm going to do the remove parameter. Okay. Now it's not passing self as a parameter. Same thing here. I'm going to, so it doesn't work very well, the mic. I mean, I'm going to remove. Okay, cool. So now we don't have that. What else can we do? Well, we have the getter and the setter for the session. We can look at the senders. I'm going to look at the actual senders of the setter because it doesn't make sense for everybody to modify that. And that's only, oh, sorry, I forgot to rename these messages. I'm going to call it start and stop. So now it makes more sense. Okay, cool. Again, so the senders for session are inside this class and it's in the start method, so it doesn't make any sense to have this setter. So I'm going to do inline method and I'm going to remove it. So we don't have the setter anymore. And I don't want anybody to get the session outside the customer system. So I'm going to look for the senders of this. And as we can see, there are a lot of senders inside the same class. So we don't need that. We could do an inline of method. But we also have these references, these senders on the test. And that's because the customer import receives the session as a parameter when it's instantiated. So what I'm going to do now is I'm going to remove the reference to the session and to use the system as a parameter. To do that, I'm going to add a parameter that I'm going to call it customer system. And this is how it's called, how I want to initialize that parameter in all the senders. The senders for this message are only in the test. And the sender I want to use, I mean, the value I want to use for those senders is customer system. That's the name of the variable that is referencing the customer system. It could be any Smalltalk collaboration here. And now I'm going to add it, something like this. If you notice, but I always use the actual scope. The actual scope is a scope that is using live typing to get the right getters, to get the right senders and implementers. So now that we have this new parameter, if we look at the senders, we will see that every time we instantiate the customer importer, we are passing the customer system as a parameter. So now I have to add the same thing here in the initialization. So I'm going to a parameter and initialize that with a customer system because it's from the instance creation method. I'm going to add it as the last parameter. Okay, cool. So now I have the customer system here. So I'm going to add this as an instance variable. This is not an automatic refactoring, so I'm going to run the test to see if everything works fine. So I'm doing this because I want the test to run all the time, okay? I'm doing all these changes using automatic refactorings because I want the test to run all the time. I don't want to have any problem when making the changes. So now that I have the customer system, I have to remove the references to the session. So I will look for the reference to it. And as we can see, there is one here and one in the initialize. So what I'm going to do is to break this reference, and I'm going to use the customer system to get the session and see if everything works. Everything works. So now I don't need the session here. And now that I don't need the session, I can remove it as an instance variable. Now that I don't need that instance variable, I don't need this parameter anymore. So I'm going to remove that parameter. So now the message is initialized from using the customer system, and I will remove that parameter from the instance creation message. And now, if I come to the persistent customer system and look for senders of the session, there are no more senders outside the class. Here, let me see. Oh, yes. Sorry. And this one, I forgot that. So I have to break that coupling there. Oh, what is it? Customer importer, evaluating customer, import customer. So I have to break this coupling here. I have to, I don't want to use the session. So how can I do that? So I want to move this collaboration to the customer system. To move this collaboration to the customer system, first I'm going to create a new method. I'm going to extract it to a new method. Now that I have the customer, I will move the add customer to the persistent customer system. But if we do this, it will pass the customer importer as a parameter, and I don't want that. And why is asking me for that parameter? It's asking me for that parameter because here I have a reference to an instance variable of the importer. So to break this coupling, what I'm going to do is to add, to extract that instance variable as a parameter. Just in the class. So as you can see, now there is no reference to instance variables, but that is the customer system, but I don't care because I'm going to move this method to the customer system. That is an instance of persistent customer system. And so we have add customer that, sends the message add customer to the customer system. And we don't need this anymore. I can do an inline of that method. So import customer sends the add customer to the customer system and everything works. And now I can come here, look for the senders of session, and those senders are only inside the persistent customer class. So I don't need this method anymore. So I'm going to do inline. And after that, there are no more getters and setters for session. So I can remove that and everything should as expected. So, okay, was the complex demo. I hope I didn't lose you. I guess I did. But anyway, the idea was to show you something complex and that you can do in 15 minutes or less if you're not doing a demo with automatic refactorings, and to think how long it will take you to do that. So based on ChatGPT data, automatic refactorings increase productivity between 30% and 20%. I asked ChatGPT, where did you get that from? It gave me some links, but they don't talk about that. So I don't know if to believe that or not. But based on my experience, automatic refactorings really increase your productivity, and we need more refactorings. In the case of Cuis, we need to improve the refactorings we have and the user interface and the user experience. And we need also to implement the undo refactorings. And to do this, we need time, and time is money. So if you want to help us, thank you. Okay, thank you very much. I don't know if there is time for question or not. Just one question. Okay. I don't have the mic. The microphone. Yeah. Yeah.
And in my experience, you find often that part of the parse tree is duplicated in several methods, but some sub node of a parse tree is not, and you might want to extract that to a parameter, and that becomes a block argument. So in the sender, now you're invoking this common method that you can map 3 or 4 methods down onto, providing that you can identify, there's this subpart of the tree which is different in all the 4 methods.
Yeah.
Right. So I hope that you're going to really push this idea of more flexible matching of parse trees, and that you don't look for identical things, because in my experience, it's never identical.
Yeah.
And in any real example, right? It's very useful when
Yeah, that's right. That was one of the goals of Marcelo's thesis, but we didn't have the time. It's a thesis work, and there is a lot to improve, but it's working really great. But the next step on that would be to recognize those kind of trees, parse trees, that are not equal but similar. And that's part of the next.
And then one last thing is that there's a great weakness in the Cuis Faro class builder. If you're doing live programming and you move instance variables, then you lose the state, because the class builder only modifies one class at a time. Yeah, but we really need somebody to do the work to make the class builder update the whole hierarchy.
Okay, if you move it in the hierarchy, if you move it in the hierarchy, yes, you're going to lose the. That's a good point. I didn't think about it. That's a great idea. Thank you. Another thesis. And I think Guillermo had a question too.
You confirm, so you are using the AST as you said, and you are using it only for identical.
To look
because
for,
you in some slide I saw that you said that you were talking about the names of the variables, like the temporary.
Like
why
here,
is
for
that?
example.
Yeah, why
Because
don't you detect that?
Because when comparing the literal variable node, A, the name of the variable is not the same as
Okay,
B.
so you're using the name.
So
okay.
we have to look for a way to, when comparing, say, okay, they're not the same name, but they're using the same place with the same semantics. And that's a little bit complex to do.
Got it.
But it's in the future work too.
And the other question is, I see that all the refactorings have this intermediate confirmation step. You have that page. Do you use it, or is it just for checking?
Yeah.
Do you have this intermediate step instead of just applying the refactoring?
Yeah, that's a good question. For example, if you want to rename this method, and it shows you this is what you're talking about. If you want to, this is because you can remove or add senders and implementers, just in case the tool didn't find everything.
Okay.
So the truth is, I never use it. I always press refactor. Okay. So it's still there, but maybe we could have like a setting or something, and trust live typing and do it.
No, I asked because I've seen in Faro they have more or less the same intermediate step. They gather all the changes composing the refactoring, and then you can select which of the changes you want to apply.
Yeah.
So,
no, I agree. The problem is that when looking for implementers and senders in a dynamically typed language, that you don't always get the right ones. With live typing, if you do the things well enough, it will be like working with an statically typed language, and you don't need this kind of confirmations. But there's something that we have to keep trying and see if we can improve it. Yeah.
Okay. Thank you.
Thank you. Thank you very much.